Hey guys, this is Mr. Sal. I'm not in. I'm just not feeling well, so you guys need to watch this video as part of the other one as well. But in any case, remember with the video, if you guys need to pause it at any time, do it so that you can get this information. As you're watching it, if you need to rewind it as well, you can do that. Or if you guys have the settings option from YouTube, you can also slow it down or speed it up. Alright, this lesson is on properties of reflections. So by the end of this lesson, and that's our objective, is that you guys should be able to perform basic reflections, usually over the axis, and we're going to change that though, but that should be the next lesson. So, we'll be able to, you got to be able to use the coordinate rules for those as well, and write them, as you can see, which is part of C right there. So right here we've got this grid, but there's something we need to notice about these points, right? Is if we were just looking at a translation, we'd be moving B to the right 6, C to the right 6, but A has been moved a different number of units to the right. In this case, it looks like it's 12 actually. So what this means is that it's kind of, it's just what it sounds like, is we're going to reflect the triangle ABC over the y-axis, which is this line. Okay, now what may help us on this may be a picture of some sort, right? So for example, you guys, if you look in the mirror, you can take some art classes or whatever, but that's your face. And let's say that you're looking in the mirror. Well, then it's like we've reflected your face to the other side of that line through the mirror. So you would have something like this. But notice, in the beginning, if we were to look at this, you were originally facing to the right, whereas now you are facing to the left. So it flips everything, right? For example, if we looked at a point on the back of your head, it is now this point on the back of your head. Okay, but something else that may be kind of interesting here is that the distance from the mirror to the back of your head to that point is the same distance in the reflection. So when you see yourself in the mirror, what's really happening is that you're seeing yourself twice the distance you are from the mirror, which is why the farther back you stand from the mirror, the less detail, I suppose, you can see. But that's the way it's going to work with reflections, and it wouldn't matter if we were looking downwards as well. So, for example, I mean, some of you guys really like old Bob Ross, right? The painter, right? He'll put some mountains over here. And then when he does it in the water, if this was a bunch of water right here, then he would have the same mountain, but upside down like this, okay? So it's the same way with reflections, whether it's up or down, or like the previous example, right or left. So that brings us back to this example. Describe the movement of a figure that has been reflected. It's just been turned around or flipped. Alright, next up we just need to identify the ordered pairs or coordinates for the preimage and the image. Of course, the preimage is this shape here, triangle ABC, and then the image is triangle A prime, B prime, C prime. So just listing these, this is something you should be able to do without a lot of trouble, because these are just the ordered pairs of the points, okay? For example, A is at -6, and that's our x value, and then y is 2, which gives us this point here, okay? And it's the same with all these other ones that we have listed. So what about the coordinate rule to describe this reflection? So again, we always start with a regular ordered pair, x, y, and then we got that arrow with the reflection above it, just so we know. But what happened in those ordered pairs? So let's go ahead and take a look at those. Notice the y values for all of the points stayed the same. So A has a y value of 2, A prime has a y value of 2. So as it turns out, it didn't change the y at all. the y values just stay the same. But what about the x values? What do you notice about A? So we got -6, and then the image is 6. B, the pre-image is -3, the image is 3, and same with C and C prime. Well, all we did is we took the x value and we found its opposite. So to show that, I'm going to make that a negative. And that's true. We just, for example, on A, where x was -6, we took the opposite of -6, which was 6. Or it's the negative of -6, which is 6. Same with C, for example. C was -3. The negative of -3 is 3. So what do you think? Do you think this rule would hold true for any figure reflected over the y-axis? Well, yeah, it doesn't matter where we are, because if we look at some random point, maybe even up here, that's at -8, 8. Well, its reflection is going to be at 8, 8. So it'll be right here. And again, the reason that is because that point is the same distance from the line of reflection to the left as it will be to the right. All right, let's go ahead and move or reflect this shape, this pre-image triangle ABC, across the x-axis, and then we'll also label the image. So first up, let's just identify that the x-axis is what we would call the line of reflection. Something like that, that'll do for me. Now if we look at this, since this is being reflected across this line, okay, this goes back to the mountain one. This is kind of like a reflection across the water. So we're going to see that A is 1 up from the x-axis. So A prime will be 1 down right here. Same with B prime. B prime is 4 up from that line of reflection. So B prime will be 4 down from that reflection. C is 2 up from that line of reflection, that x-axis. So we'll go 2 down, and that gives us C prime. And so we can see now that we have reflected triangle ABC into triangle A prime, B prime, C prime as the image. Next up, we're going to just list the ordered pairs for each point. So I'm going to give you guys a couple seconds to do that. Actually, probably a couple minutes. So give that some time and get that done. You know, we're going to say 1 minute. Here we go. 1 minute. And there's the ordered pairs that I have for both the pre-image and the image. So let's go ahead and do B. Let's write the coordinate rule to describe this reflection. So once again, we're always going to start with some xy ordered pair. And this will translate using a reflection over the x-axis specifically. And this should do something for our x and y. Now here's what I want you guys to notice, and it's similar to what we just did in the last problem reflecting over the y-axis. But this time notice these x values for all 3 points are the same in the pre-image as well as the image. They're the same. So we didn't do anything to the x values even after the transformation. But what we did do is, and we can see this, for example A, we had a 1 and it became a negative 1. B, we had a 4 and it became a negative 4. C, we had a 2 and it became a negative 2. That's the y values. So for every y value that we had, what we did is we took the opposite of that value, and that gave us the corresponding image value. So will this coordinate rule hold true for any figure reflected over the x-axis? Yes, it will. Why or why not? It's the same reasoning as the last one, except for now we're looking differently in terms of horizontally and vertically. So yes, and this is what I have. The pre-image does not move horizontally and is in the opposite direction vertically. So that's just demonstrating what we just showed. For example, C is above the line of reflection, but C prime is below, but the same distance from that line that we reflected over. All right, now I'll go and look back at numbers 1 and 2 and look at some of the properties of reflections. Starting with A, we're going to go back to number 1. Draw a segment connecting B and B prime. We kind of did that in the one that we did. A and A prime, C and C prime. We're going to make at least 2 conjectures about this relationship between the line of reflection and the segments connecting corresponding vertices in the image and pre-image of a reflection. All that means we're going to write some sentences about this, okay? All right, here are the 2 that I have. So specifically the line segments connecting corresponding vertices are parallel to each other and perpendicular to the line of reflection. So what that means is that, for example, like on number 1, right, we had the line of reflection, and then if we had this point here and reflected it across the line, would go in the opposite direction to get this point, right? Same with any other point. If this one was here, the image value would be about right here, right? What that's saying is that these lines connecting those 2 are parallel to each other, but in addition to that, they're also perpendicular to the line of reflection, which is the line in black right there. And that also means that the line of reflection in black is also halfway between the pre-image point and the image point. So what that means also, and we're going to be talking about these a little bit later, you'll hear this a lot in 9th grade, but the line of reflection is the perpendicular bisector of the line segments connecting corresponding vertices. And that means also that it doesn't matter where the line of reflection is, that will always be true. So yes, it would hold for number 2 as well. So what about problem number 1? For translation, we learned that corresponding segments are parallel or they have the same slope, but this is not going to be true for reflections. So again, this is no because, and let's look at an example of this. If this is my line of reflection, and if I have these 2 points connected by this line, then the reflection would produce perhaps something like this, but the line's slope has changed. The one in red has a positive slope, whereas the purple one has a negative slope because of the reflection. Now this would be the same thing for a horizontal reflection as well. If that was our red line right there, the purple line would be perhaps reflected, and again it becomes negative, a negative slope. So part D here, we're just going to confirm that. Going back to problem number 2, which was the reflection over the x-axis, go and take a moment and find the slopes of all 6 of these, and then we'll show you what they are here in a minute. So this just confirms all 6 of these show that their corresponding segments in the triangles are actually opposites right there. So let's compare the slopes of the corresponding segments of the image and preimage. What do you notice about the slopes? And how does this connect to the rule that we had made? XY is translated, or transformed rather, into x negative y. Well, we took the y values, 3, and we made it negative. This y value became a negative. This negative became its opposite, positive 2. So that's how that's working. Notice the x values, or the horizontal change in each of these, remained the same, just like the x did here. So once again, just take a moment and look back at problems 1 and 2. What do you notice about the lengths of the corresponding segments? So you could look at example 1. This is example 2, and we can see that the length of the segments are going to be exactly the same no matter which segment we're considering. So A prime, C prime in green and AC are the same lengths. Same with A prime, B prime, and AB, and also BC here and B prime, C prime. They're the same lengths because we haven't really changed the size of the shape, just its orientation. So that's what I'm going to write here for F. Corresponding side lengths are the same. We could also say they're congruent. For now, that's going to mean the same thing. I'm going to give you guys, let's give you guys 2 minutes to reflect this trapezoid A, B, C, D across the line y equals -1. So I'm going to draw for this, for you guys, the line of reflection. That's at y equals -1, which would be right here, okay? Now we're going to reflect it over this y equals -1 line, and you can write down the coordinates for the preimage and image, and then also try to write a coordinate rule, right? So that also should start with some kind of xy like this. Give us an arrow. Then we know it's a reflection over y equals -1. Then we'll just fill in the values as we find them. Alright, if you need more time, you're going to need to pause the video, but I'm going to go ahead and write at least the coordinates for the pre-image. Alright, there we go. Now let's go ahead and look to reflect this thing. So I'm going to start with D and C first. D is 2 above the line of reflection, so I'm going to go 2 below it, and that will give me D prime. C also is 2 above it, so I'm going to go 2 below it to get C prime. Next up, we can look at the A value, which is 2, 4, 6 above. So I've got to go 2, 4, 6 below, which is going to give me this point, A prime. B prime as well is 6 above, so B is 6 above, so B prime will be 6 below. There's B prime. Then I simply connect these points with a line like this. So there we go. Next, I need to list the ordered pairs, the coordinates for the image, starting with A prime. So there we go. Now the last part on this is the coordinate rule for this line of reflection. And what we do is we look at and see what is the difference between reflecting this over just the x-axis. Well, notice the x values never changed on this, and just reflecting it over the x-axis there in green would have given us some kind of negative y, right? So what that means is we would have, for example, looking at C, that would have reflected right here, and that is at 8, -1, but then we had to move it down 2. So from negative y, we went down 2. The question is, does this work for all of them? Well, let's see. A was 5 above the green line, so if we went 5 below, it would be right here, and then it moved down 2. So reflections will always work this way. Notice the x didn't change, but our y value became its opposite, but then we had to move it down 2. So this is only for horizontal and vertical flips. We treat the coordinate rule the exact same as if we were doing it over just the axis and then seeing how far it was moved. And it's kind of related to how that works with the reflection of what would be the line of reflection over the axis, okay? Right, there's 2 spaces in between these as well. Alright, take a moment and try this one. I'm going to draw where the line of reflection is. Some of you guys know that it's where x is -5, and that would be this line right here. So we're going to reflect triangle ABC over that line, x equals -5. I'm going to give you guys 1 minute to do this because it's not asking for all the ordered pairs and things. Alright, here we go. So we have B, which is exactly 5 units away to the right of that line of reflection. So we need to go 5 units to the left, and that would give us B prime. A is 2 units away to the right, so A prime will be 2 units to the left. And C prime
It appears as 8 units away to the right, so we've got to go 8 units to the left, and that gives us C prime. The nice thing about this is all we need to do is connect these image points with some lines, and that is the reflection. It's not a perfect drawing, but it will do. So that is reflected now over the line x equals -5. All right, let's go ahead and reflect triangle ABC over the y-axis. And the y-axis, just to clarify, is this line going right through the middle. Now, some of you guys are looking at this thinking, how the heck are we going to do this thing? As it turns out, we're just going to look at distances the points are away from the line and then move them in the other direction the same distance from the line. So B, for example, how far away is B from the line? 0. So B prime would be 0 in the other direction, which really just puts it at that point. C is 3 to the right, so C prime will be 3 to the left. C prime. A is 3 to the left, so A prime will be 3 to the right. And that is A prime. Next up, you know what to do. Just need to connect these points with lines. So that is it. The triangle in green would be the image of triangle ABC. Now, before we start on 7, it's important for you guys to remember that the line of reflection is the perpendicular bisector of the point of the line that connects the image point to the pre-image point. Now, what we have there in triangle ABC is the pre-image, so the line that you see there diagonally is going to be halfway and perpendicular to where C prime would be. Now, there's something else we need to remember on this, and that is that lines that are perpendicular to each other make 90-degree angles. Their slopes are opposite reciprocals. So we'll get back to that in a moment, but first what we want to do is identify what that means. So this slope of this line here is 1 over 1. So the opposite reciprocal of 1 over 1 is going to be -1 over 1. So that means if I took C, I need a slope of down 1 to the right 1, down 1 to the right 1, and I continue this until I reach the line. So how many sets did that take to create this line? Well, it looks like there's 4 steps. So in the other direction, I'm going to go 4 steps at the same slope. Down 1 to the right 1, there's 1, 2, 3, 4, and this point now is C prime. I'm going to do the same thing with B. So how far away is B? 1 step, 2 step, 3 step, 4, and that creates this line. And we're going to do it the same on the other side. 1, 2, 3, 4 steps, and that is where B prime would be. And then finally A, 1, 2, 3, 4, 5, 6 steps. But I've got to go in the other direction the same number of steps. 1, 2, 3, 4, 5, 6. And that is where A prime is. So the final step here is just to connect the dots, and that gives us the reflection. Next up, let's go ahead and just label the points, the coordinates of the vertices for both the pre-image and image. Alright, so there's all 6 of the vertices, the points. And next up, part C, we want the coordinate rule for this. That's good. We are reflecting over the line x equals y, or y equals x, doesn't really matter. And what did we do with these ordered pairs? Now some of you guys noticed this. In the ordered pairs, for example A, what happened to the numbers? All they did was switch. See, that's what it means that y is now the x. Y equals x. Same with B, it was -3, 5, now it's 5, -3. C is the same way, it's just switched the x and y values. So how do we do that in an ordered pair coordinate rule? We just take the y value where it was, and now I place it where the x value is. Same with the x value, I change it and put it where the y value is. That's all we did in these ordered pairs right here as well. And yes, this will work all the time for any line reflected over the line y equals x, because it's just showing that we're changing the x and y value. It worked for those three. We could say they're random points, so it will work for any point. Next, go and take a moment and find the slopes of all 6 of those line segments. And then after about a minute, we're going to show you what those slopes are. So there are the slopes. We're going to compare this with the coordinate rule, right? Notice the x and y just switched, but it's kind of like they reciprocated in the ordered pair. Same with the slope. These are going to reciprocate. So whereas AB was 1/5, A prime B prime is 5/1. Same with these other two sets of slopes. The corresponding slope will be reciprocated, but it is not opposited. All right, then G, the coordinate rule for a line reflected across the line y equals -x. That one's not too bad. Again, we're going to start with x and y, right? And we're going to reflect this over y equals -x. So we're going to switch the y and the x again, but now that it's a -x, we're going to make these negatives as well. So that does it for the lesson. Hopefully you guys got it down. So make sure you do your homework. If you need to, refer back to this video and check on them. If you guys have questions, bring them back. I'll answer those when I get back.